Okay, we've got question number 11 here. So the question is, determine the inverse of 3, 5, 2, 4. Now this is a solution. Now let me take A to be as 3, 5, 2, 4. Therefore A inverse is given as joint of A divided by modulus of A. Now this modulus of A is nothing but the determinant of A. So we will have to get the determinant of 3, 5, 2, 4, which is nothing but 3 multiplied with 4, negative 2 times 5, which can be rewritten as 12 negative 10, which is equal to 2. So therefore the determinant of A is 2. So now we need to get the adjoint of A. So the adjoint of A is nothing but you interchange 4 with 3 and you multiply a negative sign along this diagonal. So negative 2 and negative 5. So therefore A inverse is going to be the matrix 4, negative 5, negative 2 and 3 multiplied with 1 over 2, the determinant. So this can be rewritten as 4 over 2, negative 5 over 2, negative 2 over 2, 3 over 2, which is nothing but 2 divides 4 2 times. I can rewrite this as 5 over 2, the negative sign. 2 gets cancelled, giving me negative 1, and this is 3 over 2. And this is the inverse matrix. Now this is question 11b. It says the transformation m equal to 0 b a 0 maps the points R and T onto R dash and T dash such that R of 7, 2 becomes R dash of 2, negative 7, and T of negative 5, 4 becomes T dash of 4, 5. Now we will have to determine the values of A and B. And number 2 is to describe the transformation. So what happens is, this is a solution for the first question. 0 A B 0, this is hitting 7 2 and it transforms 7 2 to negative 7. So multiply row with the column. 0 times 7 plus A times 2 is equal to 2, and B times 7 positive 0 times 2 is equal to negative 7. So you get 2A is equal to 2 and 7B is equal to negative 7. Dividing by 2 you get A is equal to 1, and dividing by 7 you get B is equal to negative 1. So that is the value for A and B. Okay, now we are asked to describe the transformation M. Now M is actually 0, negative 1, 1 and 0. So this is nothing but represents a 90-degree clockwise rotation about the origin. So that's a solution for this question. next is a question on vectors. Okay, this is the next question. We got a parallelogram. So this is B, W, X and Y, and this is a point here, and then we got B and A here. It's given that S is on WY such that WS colon SY is equal to 1:2. This information is given. We are asked to first find WY vector. Now WY vector is over here. So I can write WY as WV plus BY vector. Now VY vector is clearly A vector, but WV vector is going to be negative B because of the direction. So I can rewrite this as A vector negative B vector is equal to WY vector. So that's the solution for that question. Now next we need to write WS. Now clearly from the figure we know WS vector is 1/3 WY vector, which is going to be WY is going to be A vector negative B vector. Okay, so I can rewrite this as 1/3 A vector negative 1/3 B vector, and this is WS. Okay, next we will have to write Sx vector. Now Sx vector is nothing but SW vector plus Wx vector. Now Wx vector is clearly A vector, but SW we only have WS, so to write SW we need to take in a negative sign, so it's going to be negative 1/3 A vector negative 1/3 B vector, which is going to be positive, in fact only after we club. So what we can do is A vector negative 1/3 A vector, so this is going to be positive 2A vector over 3. So I'm going to write that. So 2A vector over 3 followed by positive 1/3 B vector. Okay, so this is my Sx vector. Next we have to show Rx, X are collinear. Now R is a point, R is on the midpoint of WV, so we can write Rx vector as RW vector plus Wx vector. Now Wx vector is A vector, Rw is nothing but half of B, right? So this is going to be A vector positive 1/2 B vector, which is Rx vector. Now we've got Rx. Now let me write, or let me find out what is Sx. Now my Sx vector is 2/3 A vector plus 1/3 B vector. Now can I write this excuse me, 2/3 of A vector plus 1/2 times of B vector? Can I write it like this? Of course I can write it like this, but what is this? This is nothing but A vector positive 1/2 B vector is equal to Rx vector. So this is equal to 2/3 Rx vector, which is in turn is equal to Sx vector. Now since Sx vector is scalar times of Rx vector, they are parallel. Also, since R is the common point for both vectors, this means R, S, X are collinear. So collinear means lying on the same point. So that is the conclusion for this question. Thank you everybody.